Yeah, cheers, Jim. Can you hear me okay?
Yeah, all good, mate.
We're all good, sir. Yeah, so yeah, our first virtual meetup, which is not great in the circumstances, but also great that we can actually reach out far and wide actually and get both OWASP and in particular OWASP Birmingham a bit more in focus as well. Kind of why me and Jim restarted the chapter probably 14, 15 months ago was to try and advertise our wares, what we can do in Birmingham, but also put events on like these, whether in person or virtually, to spread the OWASP message, which does great things out there, of course. So a quick heads up who we are. We've you just heard from Jim. I'm Nathan. They're our Twitter handles, and they're all our social media stuff. Hopefully, I've got a slide right at the very end that we'll put on right at the very end of the meetup, with a reminder of those. But please feel free to follow us on Twitter individually and also OWASP Birmingham. There's a LinkedIn group, and no doubt you've all come via the meetup page and signed up, which is fantastic. So it'd be great to get as many of you following and joining us on social media. We've also got Slack channel as well, and I'll come back to that a bit later on. So some of you, I'm conscious, may actually be not only new to OWASP Birmingham, but new to OWASP itself. So just in case you are, then perhaps I'll just spend just a minute or two giving you a bit of a heads up on what OWASP is. So as it says there, we're a free and open community. We're all about AppSec and improving the security posture of the applications. Now, it's a bit of a cliche, but there's digital transformation ongoing at the moment massively. In fact, this pandemic is probably only adding to that as well. Everything is an application. So the importance now of application security has just skyrocketed compared to even when OWASP started back in the day. So there should be even a more focus on making sure that we're secure by design and using the great resources that we have to make sure our daily lives when we're consuming apps are as safe as possible. Yeah, it's all about, so what OWASP is all about is providing the visibility, providing the collateral, providing the events, the meetups, the information where we can all make those informed decisions. We can take that back to our day jobs and hopefully create a more secure application landscape. It's a voluntary-led organisation. Everyone is free to participate. So I'd encourage you to go to OWASP.org and see what's on there. But meetups are all free. Events are free. We'll have conferences as well, where if you're a member, you'll get discounts as well. Talks like this are obviously always free, and lots of collateral on the website, whether that's OWASP Top 10, that probably is OWASP most famous for, but the cheat sheet series, yeah, just loads of collateral on OWASP website. So I'd encourage you, perhaps at the end or perhaps in the next few days, to take away to go and see OWASP.org and see all the good stuff that's on there. Yes, you can see that we're built off chapters. So we have a global board, but we're very much a local chapters organisation, 160 around the world, probably a lot more than that since that slide was put on. Yeah, spread out everywhere really. And yeah, just to confirm that we are all volunteers, apart from a handful of, I think, board members. We all do this for well, we all do it for the enjoyment, but we're all volunteers. We're all trying to help each other out in this community. And I think we are one big community. I'm kind of proud of what OWASP does and what AppSec people, fellows in general, do for each other. So I think, oh yeah, so encourage you all, if you like what you see, if you're able to dig around on the OWASP website and take a look at some of the collateral. This may not be your first event that you've attended, for example. We've done a few in Birmingham, but there's loads going on elsewhere. So if you're not yet a member, but like what you see, you want to help OWASP do bigger and better things to progress, then $50 a year is the individual membership, and hey, look at that, $20 if you're a student as well. So encourage you, if you are getting value out of OWASP, to spread the word, become a member, and help move, keep OWASP at the forefront of application security. Right, I think we've gone through the agenda, so we can probably skip through this one, okay. But I wanted to highlight actually that there is a chat feature, of course, that I did have on my screen, but seems to have gone. There is a chat feature. So if anyone's got any questions throughout the course of the evening, the next couple of hours, then I'd encourage you to drop your questions in the chat, and myself and Jim will keep an eye on them and can then relay them to the speakers. We do have 2 speakers that have been in the industry for probably longer than they would like me to mention. They have got a wealth of experience, so it's a fantastic opportunity, no matter where you are in your AppSec career, to pick their brains and to ask some questions, because I'm no doubt they'll both, from hearing them before and speaking to them, they'll both have opinions that'll be worth listening to, and there'll be some great answers. So openly encourage you to take advantage of this great opportunity we have. And I think that's about the intro, Jim. Although I can't see the slides anymore.
Yeah, cool. So so Keith, do you want to share your screen?
Yeah. So let me do that. Let me know as soon as you see this very garish pink screen come up.
Sounds good. And just to reiterate, if folks have got questions for Keith as we go through, chuck them onto the chat channel, and then Nathan and I can fire a couple of questions at Keith at the end.
Yeah, and while Keith's doing that, so it's fair to say that, yeah, Keith is an very experienced DevSecOps consultant. I think he's, I remind myself, Keith, of your bio. You've probably been every role in your career: CISO, CTO, dog's body, team maker, probably everything really.
Pretty much. Just to let you know, I've just got a pop-up on my Mac that says Zoom US will not be able to record the contents of your screen until it's quit. So unfortunately, I'm going to have to quit quickly.
And then rejoin.
But I'll rejoin.
If you quit then rejoin, then we'll just
hold.
We'll just pad.
Just hold fire.
We'll do a song and dance number or something of that nature.
But yeah, but I was going to say that
he's back now.
Yeah, that's it. Yeah, but he's spoken at InfoSec, Black Hat, but it's his first time speaking at an OWASP event. Yeah, a newbie in that respect.
Jeff actually pinged me on LinkedIn and said, well, you know, it's with these interactive sessions rather than face to face. Sometimes it's difficult to make it, you know, really interactive, and so really encourage those. What did you call them, Jeff? Tricky questions.
Yeah, I love the hard questions. Bring your worst. It makes it a lot more fun for everybody.
So have a think about that as we're listening to the talks, and throw them into the chat, and Nathan and I'll pick a few out and call them out, and hopefully we can have some really good discussion. So I can see a big purple something, Keith. DevSecOps. Yeah, I think we can see it. Are you? You must be.
Can't hear you, Keith. Are you muted?
There we go. Unmuted.
Cool. Technology.
Oh, it's bizarre, isn't it, when its default is to flipping well mute you. But first of all, let me say thank you for everybody that's joined in at the moment. Let's give you a little bit of context here. So, as Nathan alluded to, I've been around a few years, you know, more than I could possibly want to admit to. And I started off, as a lot of good people do, by becoming a software engineer. You know, technology has fascinated me since I was a kid, and I also can and still do code. You know, I think it's important for somebody like myself to retain a level of credibility with technologists. And For the last few years, security has been my absolute passion. And the reason for that is we live in an ever more connected society, and we need to ensure that we protect ourselves and others as best we can. So there you go, a little bit about me. And of course, the topic here, you know, a jump to the left, you know. Yes, I'm talking about left shifting of security from traditional cybersecurity operations type activities into the development communities. For me, there's always been a risk that cybersecurity is something that is an afterthought, and we need to be able to protect ourselves and protect our assets much more diligently than we ever did. It's the old adage of hackers only need to be lucky once is very, very true. And despite what the general public think, most hackers aren't very sophisticated. They're predominantly script kiddies. But the ones that are more sophisticated have lots of access to good quality tools to really exploit situations as much as they can. So what do we need to do? We need to make sure that people start thinking about security from the very beginning of when they're building a product or making a change, enabling security to be baked in at the very beginning, you know, so that you actually start off with a situation where you can build your confidence over time. And of course, the only way to successfully do that is using automation. You know, so you use whatever tools you can to automate those processes and use the data from those tools to make good, relevant decisions. There's a really good reason why you want to move security as close to your development and architecture even practices as possible. And that's because the actual relative costs of finding and fixing security defects get significantly higher over time. In actual fact, you know, I produced this graph and I couldn't be bothered to do a logarithmic scale, which is what's really needed. Because once you get into production, you know, the chances are that those security defects are now vulnerabilities. And if they're exploited, you're into a whole different ballgame. You know, with things like GDPR, the chances are that if it's found in production, there has been a leak of data. And if you have data leakage, your company can be, or the target organization, can be liable for up to 4% of its global annual turnover from the previous year. Now, those can be very, very scary numbers. So the guiding principles for me is that nowadays security is everybody's responsibility. It's not acceptable for a developer to say, well, you know, what do I care about security? That's somebody else's problem. In order to do that, you really do need to automate security checks as much as possible. And you have to make sure that whatever tools you use give good quality, actionable feedback. And it's all about that time to respond, which is really important. Because that data and the learnings that you get from seeing your security defects presented to you will allow you to improve your position on security over time. Now, I've actually done this at scale and pace, as their friends from Contrast will attest. Together, we have actually done this, and it wasn't a small undertaking. But in essence, if I was to look at an ideal situation, this is essentially an unpacked DevOps cycle, right? But first and foremost, in design, do some even rudimentary threat analysis. People actually get a little bit scared by it because they think that there's some, hocus pocus going on. But the identification of what your critical assets are that somebody would like to steal, identify how they could possibly do it, and then figure out how you'd stop them. I mean, that's the core to a very simple threat modeling. And again, as you're coding, you need to have feedback to show you where your potential vulnerabilities lie. So you need to have good quality, what I call security helper tools and scanning tools. When you're building your application, again, sort of like make sure that nowadays you're using automated pipelines. There's great stuff available now. Jenkins X, Kubernetes for managing your clusters and helping that look at the integrity of your Docker containers and stuff like that. Make sure that whatever you are designing, you're able to test in an automated fashion. Take the heavy lifting off, because we're talking about cycles. When you have a 2-week sprint, you don't want to be waiting 1 day, 2 days, 3 days, even a week to get some feedback on your code quality and identification of where your potential vulnerabilities lie. And again, sort of like, if you can, make sure that you're gathering good quality metrics so that you can actually feed that data back. It is so important, because if you can't see how you're going to improve if you don't have the data. Importantly, just as importantly here though, is to identify metrics that matter. Lots of tools will give you lots of metrics, and it's easy to become overwhelmed. So how do you get started? Well, it's a journey, and the thing with any journey is start slow and actually build up, because otherwise you can very, very quickly run out of energy and resources also. So as I said earlier, look at some simple threat modeling. It really can be this simple, because what you want is to be able to utilize your automated tools to be able to do all the heavy lifting for you at some point. But before we get there, you need to make sure that developers and others around you actually understand the fundamentals of security and apply it mindfully. I mean, I have lost count of the number of developers that have come to me and said, well, I've got these defects, but I don't understand it. I said, well, why don't you understand it? I said, well, I got this code off of off of GitHub and put it in my IDE. You know, I didn't actually write it. And I said, well, unfortunately, you know, as soon as you've got your hand on the keyboard, you've got a moral responsibility to ensure that the code that you are submitting has a relatively good quality of security applied to it. So it is really important to do your learning, understand what the common CVEs are. Common CVEs are the most common vulnerabilities that are, and exploits which are that are published. OWASP has their top 10. MITRE has one. There's a whole bunch of them. They're all really good, and they do give you good quality remediation advice on them. Also, in organisations, I would actually ask people to actually go a little bit further and become security champions. You know, it really makes a difference, and you know there are excellent learning opportunities which are available. So our friends at Contrast actually have one. OWASP has Juice Shop. You know, there's a lot of them that allow you to learn and operate in sandboxes so you can try stuff out. Spend some time, have a play. You know, it's the fun of being an engineer. But also, you know, if you are starting out, choose security tooling that fits your need at that time. You know, there's lots of open source products available. But, you know, when you get to doing things at scale and pace, there is no substitute for some of the good quality commercial tools. And I've been very, very lucky in working with some of the best providers of that. But also, once you actually get your feedback, get to understand what constitutes these defects, how they manifest themselves. The reason that I said about the different types of tools is because they have differing levels of ability to give you true positive. So at some point you will be working with tools which will flag up, you know, thousands of potential vulnerabilities. That's why I differentiate them and call them deep security defects as against vulnerabilities. So it's really important to be able to get that understanding and educate yourselves. So all of this, it sounds really easy, doesn't it? And the reality is, with the right tools, that technology side is absolutely easy. You know, the good quality tooling and support that you get makes that aspect a relative breeze. But people change really is hard. Not just in security, in any sort of transformation. And that's because humans are not computers. They're really not. So you have to understand, you know, what drives people. And people are driven by goals. You know, give specific goals. Make sure that people actually have access to the materials that will allow them to achieve those goals, and actually notice when it happens. People like positive affirmation. So, you know, even if it's small steps, you know, showing that positive move gets a lot more distance than just bland data. Yeah, okay. So right at the very beginning, I said it's a step to the left, a jump to the left, and then a step to the right. What I mean by that is quite often, especially when you work with some larger organizations, you have to be able to educate the architects, the security people, other technologists around what it means to work in an agile or DevOps, DevSecOps mode. Some people become very resistant, and you have to take them on that journey. The resistance is basically around, okay, I do security. I do it at the end after you've produced this, and I'm a hard quality gate. Now that doesn't really work in the modern era. So you have to be able to explain to them that you're not compromising security in anything. If anything, you're actually improving it. And so you have to point out those benefits and the fact that they're not going to become extraneous overnight. The reality is that all of the tools that we currently have available understand the known knowns, not the unknowns. Now, there are going to be people messing around with bots and AI, ML, and all of this good stuff, trying to use it to develop new techniques for identifying and attacking potential vulnerability in systems. Well, you need to be looking at what's coming down the road 18, 20 months, 24 months away. Security changes, it changes all of the time. So you're not talking about replacing, you're talking about expanding. If we don't start looking at the future threats, then we'll get hit hard. And that's not what we want. But there's a big payoff in shifting left, and that is a competitive advantage. Literally, you can expect to see, a good 30% reduction in your time to market, but also the actual relative costs of delivering your product can come down, especially when you're utilizing appropriate levels of automation to actually get your cycles done more effectively. So anyway, so that's my little pitch for today. You can get me on social media, email me, reach out to Grant, Nathan, or any other guys, and I am very, very looking forward to Jeff and the guys from Contrast. So thank you.
Thanks, Keith. Can I fire the first question?
Absolutely.
So, well, first is a comment, actually. I actually watched another video a week or so ago about, I know a lot of people try and bemoan cliches and buzzwords, and shift left is one of those now alongside DevSecOps. And some people get on the bandwagon, don't like those kind of terms, but if it helps, then all good for me. And they talked about exactly what you said, actually. Rather than just shift left, we're actually expanding left. The right is still important. We're not going anywhere. We're just trying to make it more pervasive over the life cycle. So yeah, I do take that on board and agree with that. My question though, us folk that have been in security for a while, we're often the gatekeepers, or the people that like to say no. We often have our clipboard and our tick box and exercise to make sure before anything can roll out, or hopefully. But how pragmatic should we start to become in security around what does get released? Do we, I assume we can't just be that stick in the mud at the end, even if we're trying to be more pervasive in the SDLC. If we're trying to be everywhere and help, there's a level of pragmatism and realism needs to start, filtering into the hearts and minds of us security folk.
So this is where I talk about the incremental improvements in security posture. So right at the very beginning, it is, for me, it's unacceptable for any design not to have had security input into it. Okay, and I see it a lot. People go, oh yeah, and we're going to have this layer here, and we're going to have an imperva WAF, and that's fine because that will pick up the OWASP top 10. Yeah, that's fine. And I say, okay, have you any idea how easy it is to bypass an imperva WAF? Well, no. I said, well, that's why you need to engage somebody that knows a bit about these things. It's so baking it in at the very beginning, and then making sure that throughout that process, when you're gathering data and you have metrics that you can use to demonstrate where you are from a security perspective, a lot of the older types of security practice that I've seen, literally, oh yeah, we're going to do a code review. Oh yeah. Why would they wait for you to do a code review at the end of your 4-week sprint when they can demonstrate that they've had a continuous scanning of their repos over that time, and that they've been getting feedback, and and we can show that the JIRA tickets have been picked up and pushed back into their backlog, and that they're being groomed appropriately. So, and we're seeing this reduction. It makes no sense to me that we can't say that the ideal is to actually have a demonstrated security position on a continual basis. Again, it is absolutely additive. Yes, you can have a go no go, but it will be on the basis of good quality data, not somebody having to go and sift through and then make a decision. These decisioning processes should be very, very quick.
Yeah, no, absolutely. We've got a question in from someone else, actually, Keith, if you're ready.
Hey.
This is from Roger. So, do cost savings? You talked about cost savings at the towards the back end of your slides there, about how shifting left correctly can, or shifting left can create cost savings. But the question from Roger is that only when it's done correctly, or what about if you shift left? If you do it in a poor way, could that actually be
so the reality for me is that if you are engaging in a modern delivery life cycle, what you want is to be able to fix defects within your sprints. Okay, that is what reduces the amount of rework, and rework is stuff that kills your product. So, any sort of shifting left will give you incremental savings. It has to, because the whole point is that you are actually, you know what, David, I should have turned the chat off because I've just focused on your chat message here. It's all about getting things resolved in a quicker way.
That actually would make a great metric. I was just thinking, Keith, just as a reflection on your talk. If you've got security defects getting resolved, if you've got vulnerabilities getting fixed in your sprint, then you're winning, right?
Yeah, because if you look at the costs of remediation, that's the fundamental reason why you really want to do it as early as you can.
Yeah, no, definitely. So we've got another question from Roger, which he's been deliberately vague and naive about. So so I'm going to rephrase it. Why do developers need to worry about this? Why can't we just build a set of languages and components that we can plug together in a secure way from the start? Is that even a sensible vision for the industry?
And for me, it's an education thing. If you're a developer and you develop in a way in which will introduce vulnerability, that's bad. It's a mindset. And for me, look at SQL injection vulnerabilities. Look at cross-site scripting vulnerabilities. These things have been around for 20 odd years, and people still write the most horrific code that allow these things to persist. And Grant is nodding his head because he has seen some of the worst when we were working together. For me, it's a pride thing. As an ex-developer myself, I don't feel that there are any developers out there that set out to write bad code, okay, purposefully. They do it because they don't understand fully the consequences of what they're writing, and that comes down to the fact that you look at any of the university courses, none of them actually really touch on defensive programming and stuff like that.
Yeah, so got a question from Grant actually, and I would preface this by saying I would eat my hat if there's not a whole bunch of pen testers on the call. But how do you feel about pen testing?
Well, pen testing absolutely has its place. It is really important because on an annual basis, you should be doing it as part of your DR and BCP planning. All right, there are lots of what I would call robotic pen testing solutions available. Most DAST scanners do a level of that, especially some of the more modern ones which use access to your source code and machine learning to actually understand how your application works and then try to break it. But again, pen testers will try a lot more different things, and where I was working before, they had some very, very clever white hat hackers whose basic starting point would be the BIOS on their laptop and work up from that. Very technical, and that is the exception. But there is absolutely a place for manual pen testing. It's a method of validation and verification.
Go on, Nathan.
Well, that's good. That's good, Keith, because 6 months ago I was given pen testers to look after as well. So I'm glad you said that. For my sins, I don't know why they gave it to me, but anyway, we got a question in about product owners.
Yep.
How do we engage with product owners? How do we get them on board? And are they the key?
Well, absolutely. So, as a product owner, you need to understand what your product is, how it's going to be used, and as part of that, you should be absolutely familiar with those assets that would be valuable for a hacker to steal. as a product owner, you absolutely want to, so a level of confidence that your product is going to be secure, because reputation is a massive thing. You know, outside of any sort of financial gains, the reputation with your consumers is absolutely paramount.
Oh, so here we go. Abdo is asking, in a large organization, a complex organization, how would you structure a DevSecOps transformation initiative? You mentioned threat modeling, automation. How would you sequence it? How would you sequence that kind of transformation?
Well, again, the first thing is to understand where you are. With any sort of transformation can be a harrowing experience, and you need to be very clear about where you currently are. You need to absolutely describe your journey and what the end state is, and engage with all of the different technologists to come together. The way in which Grant and I went about this was the creation of communities of practice, getting people involved, and that's how we built out, security champions, and provided people with tools outside of the standard AppSec stuff. The ability for them to come together in these communities, having a good quality developer's handbook, which was completely extensible. Okay, and it was built specifically in that way, such that people could and were encouraged to build extensions. I mean, one of the things that I'd say there is that when I went to Mexico and was talking to the development team out there, they said, can we write extensions in Spanish? I went, absolutely. This is exactly why we've built it in this way. It's for you to be able to have your own customizations, to be able to, this team here uses a different type of cloud environment to this team there. There may be subtle differences. And so you have to have an environment where people can actually get this down and learn from each other. So I'm just reading the note here from Abdo.
Yeah.
So the interesting thing there for me is SCA tools. So SCA tools are fundamentally important. You wouldn't believe the amount of times that I've seen libraries which are, 10, 15 years out of date, that have got a CVE list as long as your arm. But people don't understand that, well, I'm just calling this library. And you don't need it. So when I talk about an end-to-end security view, the CI/CD pipeline is the meat in the sandwich. And there's pre and post pipeline activities which are needed. And so certainly SCA type of activities can be done on a scheduled basis on your code base. Okay, and good quality feedback on a daily basis. So hopefully, if you take it in the round, you look at, CI/CD is the meat, but there are activities before and after in order to actually give you that good security posture.
No, absolutely. Loads of great thoughts. So I just want to signal that we've got a break scheduled in now, which I think we'll kind of do. But obviously the Zoom call still works. If people want to keep on having a conversation, that's fine. If people want to have a little, you know, go and grab something to eat, or, you know, kind of a snack, or have a drink, that's kind of fine as well. I just wanted to signal that. But Keith, I want to pick you up on that, because yeah, so I agree about the CD pipeline, particularly with a greenfield project, or a greenfield program, or greenfield organization, if you will. But what about those complex situations where you've got issues of code ownership and you've got legacy stuff that is, you know, nobody owns it? What can you suggest in those kinds of situations?
Exactly. It's all about being able to identify you know, areas of concern, because only then are you able to actually take that to the table and say, hey, listen, you know, we really need to do something about this. I mean, legacy is a great example. I mean, but the reality is that regardless of whether it's a new or legacy, that code has to sit somewhere. And if it's somewhere, you can scan it. If you can scan it, you can get data back from it. You can use that data to drive change. And in actual fact, you know, not all of these things that are picked up by SCA are bad. I mean, in one instance, I've seen an AWS library which was 1,000 versions out of date. But guess what? There were no CVEs against it. So you have to look at that and go, would I spend time in updating that library? Well, no, because it's not doing any harm. But I've also seen situations where there is a library used by 50, 60 applications, and they're using different versions of that because nobody's actually been given enough time to make sure that they're all dragged up to the latest version, despite the fact that there's a list as long as your arm on the CVEs against it.
Cool. Well, thanks, Keith. It's good to, and thanks for being so gracious in kind of putting you on the spot on the whole Zoom, and answering all of our questions, really.
No, seriously, it's my pleasure.
And I think two things that I particularly took out was the distinction between, or making a distinction between, security defects and vulnerabilities. You know, just to kind of finesse that issue of false positives in backlogs, and that's something I'll definitely take away. And then also just a quote when you said, you know, fix defects within the sprint. I think, you know, that's a sticker that we can all have on our laptops, perhaps in the software development community.
Well, I know that Jeff is, he'll be focusing on this because, you know, the contrast solution provides very, very low false positives. You know, it's one of these things where, you know, if you use look at the tools that you're using, you know, if you've got a false positive rate of like 50-60%, hey, guess what? You're going to be doing a lot of work trying to figure out whether or not those things are true vulnerabilities or not. You really do need to focus in on the stuff that matters.
Yeah, definitely. We've got a comment from Jeff, actually. I don't know if you want to make a comment.
I will just say, you know, thank you very much, but I'm not going to be talking about contrast today. This is OWASP, and you know, I actually created the OWASP chapters. I set the rules, and really, it's not an appropriate forum for talking about, you know, our products. So I'm going to be talking about software instrumentation. I'm going to do some hands-on stuff and show you how you can actually build your own instrumentation. I think it's a lot of fun, but if you want to talk about contrast.
No. But instrumentation is absolutely key. You know, getting those good quality, that good quality data. You know, the stuff that really matters. That's what drives improvement.
What I love about security is that it's just so huge. It's such a huge topic. I mean, you know, in OWASP, we're kind of in our AppSec niche, if you like, or, you know, and also cloud security comes into it. But there's so many other aspects of security as well.
Well, I actually, I used to.
I always ask when at these kind of sessions is just to get an idea of the composition of folks that have come here. And I don't know if this will really work remotely, but typically I tend to try and label people as either coming from a software development background or more of a security background, or maybe just a complete another background entirely. And if you're comfortable just to share on the chat, you know, which direction you're coming at OWASP with, that'd be really interesting to see, really.
Yeah, great stuff. Cheers, Keith, from me, Nathan. Informative as ever. I really appreciate that. Glad you could make the time.
My pleasure. I'm looking forward to listening to Jeff.
Well, yes. Which brings us to the agenda. Yeah, so we're 5 minutes away from. Should we just take 5 more minutes? Just Jeff, do you want to get yourself set up? Sorry, and I think Dave, or you can even grab the screen yourself.
Yeah.
And then we'll kick off in, say, 5 minutes.
Yeah, cool. That sounds good.
Perfect.
Can somebody let me know if they can see that screen?
I can see how to build awesome security instrumentation to automate AppSec testing and protection. All good?
Pieces.
I was going to make a longer title, but I ran out of space.
Yeah. Pretty mouthful, isn't it? Yeah, well, I suppose. Could be much worse, couldn't it?
I hear a little OWASPer in the background. Has somebody got kids running around?
I shall hope they will at some stage, but at the moment, at the age of 6, I'm not sure yet. But to be fair, I practice my info stuff on my 10-year-old, and he understands quite well, so maybe there's the way to go for him. Who knows?
Nice.
When you have to deliver InfoSec training to non-people, you just use your own child and say, do you know what I'm saying? It works.
Okay, everyone. Hopefully that was enough time for everybody to refresh the beverage or comfort break or whatever. Yeah, really an honour to have Jeff present today. Yeah, obviously, you know, he's kind of person that needs no introduction in many respects. Certainly a big supporter of OWASP over the years, and like Keith have done every job within DevSecOps. I think Jeff has got his fingerprints on a lot of the stuff that you'll find on OWASP website. So tremendous to have him on board. OWASP Birmingham is a small chapter in the UK. You know, we're not the big fish like OWASP London. Hey, but we're trying to do our best to spread that message. And for Jeff, can I just say that thank you for, and thank Dave as well, who's managed to facilitate that, and Lindsay, to have you on board is great to advertise our OWASP and our own chapter as well. So thanks again, Jeff, and I'll pass over the reins to you. Looking forward to it.
All right, thanks so much for having me. Again, my name's Jeff Williams. I'm super excited to talk to you about the magic of security instrumentation today. As you mentioned, I've been in the AppSec industry for a really long time. I started one of the world's first application security consulting companies back in the early 2000s. And I also helped to start OWASP. I was the first global chair of OWASP for 10 years. And I set up the chapters program. I wrote the OWASP Top 10. I built the wiki, contributed to a whole bunch of different projects. I wrote a SAPI, I wrote WebGoat, and a bunch of other things. So I'm super passionate about application security. Today, I'm the co-founder and CTO of Contrast Security. We offer a complete DevSecOps platform that covers application security testing, library analysis, and runtime protection. So, you know, a lot of different kinds of products together. I'm at home in Maryland with my wife and 3 of my 4 kids. I wish I could have been there face to face, but as we mentioned earlier, I think the best thing is to try to engage during these, these virtual meetings. So please do think up some questions and ask them in the chat, or, you know, when I'm done, please ask a question out loud, and I think that's a really fun way of trying to interact in this weird time. If some question comes to you later, by the way, you can also reach out to me on LinkedIn or Twitter. My handle's Planet Level, so you should be able to find me pretty easily. All right, let's jump into this. So I think Keith did a great job about sort of describing the problem. So I'm going to go pretty fast through this part. I'm going to use one slide to talk about the whole challenge of application security in modern software. So I see tons of organizations that are looking to deliver value to their customers faster. In fact, I heard a quote from Satya Nadella, the Microsoft CEO. He said, as COVID-19 impacts every aspect of our work and life, we've seen 2 years worth of digital transformation in the last 2 months. So he said this on the earnings call just a couple of days ago. So everyone is trying to use software to deliver value faster. And as part of that, they're trying to increase velocity, decrease complexity, drive innovation, all while managing risk, right? So the initiatives that I hear companies working on are primarily these. We hear about security modernization, we hear about DevOps, digital transformation, switching out legacy tools, breach prevention, and so on. These kinds of efforts are what companies are focusing on. And development teams are adjusting to these new demands. So they're implementing DevOps because it allows them to innovate faster. In part of their software process, it creates flow, it shortens feedback loops, it creates this culture of experimentation and learning. It's been really successful. And they're using new technologies to do this. So that's why they're adding cloud and containers. They're leveraging APIs and open source. They're building CI/CD pipelines, and they're throwing away anything that involves humans. It has to be 100% automated. And so anything that involves experts, as we were talking about in the chat, if it involves experts, you got to get rid of it because it slows down the pipeline and kills the delivery of value. The results of this have been amazing. And if you read any of the books out there, Phoenix Project or Unicorn Project or a bunch of others, you can get stats on just how revolutionary this process has been. It's actually 200 times more frequent deployments, faster recovery, lower change failure rate. It's really impressive. And so I think I saw a survey recently that said 6% of companies are not considering moving to DevOps. Okay, that's pretty compelling. I just talked to Gartner yesterday and they said everyone is doing this. So the problem is security is a major challenge here. Current teams can't keep up with this pace of software development. And so we see this, what I call broken economics. If your security team can handle a certain pace of things and the amount of code being delivered is going up 10x, there's this gap that's never going to get filled. It's impossible economics. And until we fix the economics, we're going to continue to fail at security. Actually, just throwing more tools and experts at the problem increases the complexity and friction of the process. So it actually thwarts the delivery of value, which is sort of the whole point. So you have to be really smart about how you do this. If you just throw stuff at the problem, you'll end up with security slowing down the value delivery stream. Development teams will then bypass security to achieve the velocity they set out to achieve. And security ends up as this siloed compliance check that has very little effect on development, and we'll just be in the same place we've been for a long time. So it doesn't have to be this way. We can change DevOps into DevSecOps, and we've been doing it with companies like Keith's and others at large scale. We can see radical transformations in the ability to do testing and remediation and runtime protection, and we can get rid of that security backlog and build security just as fast as we're building the systems. That's really the promise of DevSecOps. Okay, so a little bit of bad news. I've been doing this for a really long time, and I feel like I've tried everything, right? I've done high assurance work. I wrote one of the major capability maturity models. I've done pen testing and full disclosure. I've tried SAST and DAST and WAFs extensively. I've built lots of SDLCs. I've trained thousands of developers. But all of these efforts over the years, we've made essentially no progress. I mean, the OWASP Top 10 is a cool project, and we touched a lot of people, but it's essentially failed. My vision when we wrote that thing was that we'd put out the top 10, and then a few years later, we'd take off a few that we've solved, and we'd add a few new ones, and we'd raise the bar over time. But if you look at the OWASP Top 10, it's essentially exactly the same stuff that was in it when we created it in 2002. That's crazy. If you look at applications, the average number of serious vulnerabilities in an application is almost exactly the same as it was back in 2002. And it's the same vulnerabilities. We haven't stamped out a single class of vulnerability. And it's frustrating to me because I keep thinking, why? These vulnerabilities are not that complicated. If we wanted to stamp them out, we could, but we haven't. So if any of this stuff on this list down here was gonna work, it would have worked by now. Like if we could train our way out of this, we would have done it. If we could static analysis our way out of this, it would have worked by now, but it's not working. We've got to do something different. So if you take a step back and think about the problem that we're trying to solve, it's exactly the same kinds of problems that pre-DevOps software development had. Software development, when I started out, I was on a big Navy project here in the States, and there were, I don't know, 200 developers on the project, and I worked on it for 3 years, and we never shipped software once. Software was slow, it was very inaccurate, it was unpredictable, and DevOps in a lot of ways has targeted exactly those problems and made fantastic progress. It's not a silver bullet, but it's a path forward that's actually working. And so DevOps has shown us the path that we have to follow, but we have to change the way that we do security. DevOps was about changing the way that people did development. We need to change the way we do security. That's why I say DevSecOps is about changing security. It's not about changing DevOps. Read the Phoenix project, learn the 3 ways, you can see them here, and interpret them for security. We need, the first one is to establish workflow. You break down the work into little pieces so that you can track it and you don't get far off course. We can do that for security. We shouldn't write a 50-page security requirements document or build a gigantic security architecture. Instead, we should focus on very small chunks of work. Like, what's the next biggest risk? Is it SQL injection? Is it access control? Is it authentication? What's the biggest risk? Let's break that down, put that work into our process, and deliver it all the way into production with testing, with assurance, all the way through. That's the path to improving security. The second way is to ensure instant feedback. And the feedback loops we have for security are way too long. If you're pen testing at the end of the pipeline, your results are not timely enough. I know I did this for years, but the feedback loop, if it's months later, is not going to affect development. We're not going to get healthy that way. So we need instant, accurate feedback. That means we have to have accurate feedback without experts. That's the quest that I'm on. And then security culture. I think everyone would agree it's really important, but how do we do it? Well, I think we need to look at what DevOps has done and start adopting some of the principles. If you read the Unicorn Project, which came out very recently, it's a sequel to the Phoenix Project. Gene Kim articulates 5 principles for building culture, and I think we should translate those as well. That's a different talk, but I just wanted to sort of lay out my thoughts on DevSecOps to sort of layer on top of what Keith shared. I will say, be careful of people preaching about shifting left if they don't really talk about changing the way security works. I see a lot of organizations that are taking the same old activities, the same security activities, pen testing, code review, security architecture, threat modeling, and just shoving them left onto developers who don't have the skills or expertise to do those processes. That's not change. I call that shitting left, because it's just dumping onto the development teams. So we want to try to avoid that. Okay, put a pin in that for a minute. We'll come back at the end. I want to talk about instrumentation. This is the 9450. It's an instrumented basketball. And I've got one. I've been playing basketball forever, but I started using the 9450. This thing measures my dribble speed, shot rotation, the arc of the shot, how many you make, how many you miss, and a whole bunch of other stuff. And it comes with a bunch of drills and metrics. It all reports to your dashboard on your phone. It gives you coaching there on drills and stuff that you can do. And after using this thing for 1 hour, it let me know that I was shooting too flat. I needed to add more arc to my shot. It's amazing. Nobody ever told me. And I made a change and it worked. It was definitely effective. And so I think this is a whole different way to think about building a great basketball team. The player and coach can now work together much more efficiently, because the player can do a lot of the basic stuff themselves. They get a lot of data, and then the coach can look at that data and make wise decisions about coaching the player to get to a better place. This is really powerful. And all it took was a few sensors directly in my basketball. Think about how that changes whole industries. Imagine healthcare, for instance. It's a good time to think about healthcare. Imagine if everybody had a watch that told them the second they had some symptom of fever or sweating or listlessness or something. My daughter has tachycardia. She has a special sensor. When her heart rate starts going crazy, we can record her heart rate and get real data to the doctor, as opposed to trying to rush her to the hospital to get it measured in professional machines. The application performance management industry was transformed this way. When I was as part of big development projects, we used to have to hire a consultant to come in with special tools, run them for a few months, gather data, and then give us a PDF report. That was a terrible way to do performance, but it's exactly the way we're doing performance today. I'm sorry, security today. But we can revolutionize the way, we did revolutionize the way we do performance. Now you can buy a tool like AppDynamics or New Relic. Everyone can measure their own performance, make their own changes, and improve their software themselves. It's democratizing. So great news. Instrumenting software is easy and it's amazingly powerful. And this is just a high level picture showing you how it basically works, but I want you to imagine the original code down here as it loads into the platform, whether it's the JVM or .NET CLR or Ruby or Python or whatever. The instrumentation engine attaches to that process, inserts sensors directly into the code, and then what you run in any environment, in dev, in test, or in prod, is instrumented code that now monitors that code for security. It could be vulnerabilities, could be libraries, could be attacks in production. This is a way to surgically add sensors to exactly the right methods exactly measuring what you want to measure in your application. You can record and analyze the telemetry from those sensors to keep an eye on just about anything in your software. The only limit here is your imagination. And I just want you to think, in the real world, we instrument complicated things like airplanes and cars and space shuttles and factories. You know, a modern factory has thousands of sensors for temperature and vibration and smoke and noise, everything. And you'd be nuts to operate any modern technology without tons of sensors, but software is almost entirely uninstrumented. Log files are not good instrumentation. So that's what I believe the future of software is, instrumentation. And we're gonna, you know, in 3 to 5 years, you won't see any applications that are deployed without instrumentation for a bunch of things. Might be performance, might be security, might be other observability and other things. But that's where we're headed. So you can get started right now. I hate to show code on slides, but I want you to understand really how easy this is. I'm happy to share any of this with you afterwards, and my slides are going to be totally available. So instead of showing this to you in a slide, I'm going to show it to you right in my Eclipse IDE here. So here you can see this is the entire code for an instrumentation agent. This leverages a library called ByteBuddy, which is a really powerful instrumentation library for Java, but you can do this in just about any environment. What this says is create me an agent that instruments the Java SQL statement interface and any classes that extend this or implement this. So all my database drivers, and it says in the methods execute and execute query, we want to add some instrumentation. So this is the way you send unparameterized queries to a database. And what we add to those methods is this security advice. Now the security advice is really simple. It's right here. And all this says is grab the first parameter to these methods, execute and execute query. That's going to be the query. And then just print it out and show me the stack trace so I can see how that method was invoked. This gets woven into the application as it starts up. And then anytime anybody calls an unparameterized query, we'll get an alert. So let's take a look, and then we can think about how this actually works. So to use this, I'm just going to set this one environment variable, Java tool options, and I'm going to say use this Java agent that I just made, and it points it to this jar. So I'm setting that environment variable, and then I'm going to run a Tomcat here with a simple application in it called Ticket Book. So you can see here up at the top, it says, okay, I picked up the Java tool options. I've got my Java agent flag, and I initialized the Java agent. So we're going to instrument this app. And then I'm going to go to my ticket book here, and I'm just going to enter Birmingham and hit submit. And you can see the agent fired. The code that we inserted into the SQL method, this execute query method, and you can see it actually instrumented the HSQLDB execute query method. We intercepted that query and dumped it out to the command line here. So this by itself is not super impressive. This finds any unparameterized queries in your applications. And I didn't have to change any code. I can take this agent, I could say, hey, everybody in the company now, you run with this. And instead of logging it to system out, you could say, let's have this report to a centralized database. And so pretty quickly, you could find all the unparameterized queries in your enterprise and stay on top of it forever. From now on, you can monitor this. And if you have a policy that says we're not going to use unparameterized queries because they're potentially susceptible to SQL injection, then you got a pretty good defense here against finding this bad security practice. So this is we're just dipping our toe into the water of what we can do, but you can see this is really simple. So let's go on to a more advanced example. So, oh, one thing I wanted to point out is you could also throw an exception, and you could just get all your developers to use this agent all the time. And then when they run their test cases and they send an unparameterized query, you'll just fail their normal test case. Notice I didn't have to put in any attack or anything. I just put in, Birmingham, and I found this potential vulnerability. So this, we can just take it right to the developer and fail their test case with a message that says, hey, please don't use unparameterized queries, switch this over to prepared statement. Awesome. That's the way developers want to work. So I'll just talk about, the typical scanning approach has some problems with speed and scale and accuracy because the scanner is working outside the application, sending attacks in to this black box, and then the only thing it gets back is HTTP response. So, if you send in an attack and it generates a 500 error and sends the response back, well, what happened in there? Was there SQL injection, or did you break something else? It's very hard to tell what's going on because it's a black box. But using instrumentation, I want you to think about it this way. Think about, as you're doing your tests, you've got an agent inside the application that's helping you, spying on exactly what's going on inside the application. So now you can get all the details you need. You can get the exact line of code, the full query, the full HTTP request. You can get the control flow and data flow, libraries, configuration, whatever you want. You can put sensors on inside the application to make your testing much more effective, so that you might not need pen testers for a lot of this. You might be able to, the developer might be able to test themselves. And that's really when we start fixing the economics of security, is when we empower development teams. When we use the big machinery of software development, that's how we're going to scale this problem. And I think, security specialists, there's still plenty of great work for you to do. You don't have to chase XSS for the rest of your life. You can focus on harder, more interesting problems like security architecture and threat modeling and threat intelligence and access control and other hard problems, taking your knowledge and turning it into sensors that can be automated as part of the pipelines. Okay, so let's take a look at another example. This is more about observability, and you'll see in this example, let me switch back to my runtime view here. In this example, this access control agent, we're putting a lot more sensors in on a bunch of things that I want to know about that are going on inside this application. So use of encryption, any URLs that get accessed, like SSRF, anything that's, parameters that get sent in, or SQL connections, and so on. We're going to monitor all this stuff. And so let's take a look at that. I'm going to kill this and switch to my access control agent here. This is more about observability. And then we'll just run that same application again. Now this time, again, it starts up. The instrumentation all happens as this code is loading, and then it's started up now. So I'm going to use the same application, and I'm just going to click on a few of these pages here. I'm not sending any data or anything, but I'll just give you a sense of some of the kinds of things that we're collecting here. So you can see we're printing out this data every few seconds. And we've started a test coverage matrix to show you, what pages we've hit. We started an access control matrix. We're not into that yet. And here we're just gathering HTTP parameters. And what this does is it actually measures what parameters are asked for by the application for each page. So even if it's not present in the HTTP request, it might be a hidden parameter or something. This technique can find these and show you them. So really powerful for pen testing to be able to do this. I just saw a question on the chat here that says, is this possible even for code you don't own and can't directly edit, like third-party dependencies? And the answer is yes. Any code that you can run, you can instrument, including all the libraries and frameworks and even the app server and runtime itself. A lot of these instrumentation sensors go into the runtime. So let's take a look at access here. I'm going to click on these access pages. And what I'll show you is that we can very quickly see exactly what access control checks are made inside each of these pages. If you look at this access control section here, you can see access A makes a check to see if the user is in role A. Access B checks for role B. Access C, role C. That all sort of makes sense. Access D, no access control check. That's a little weird. Maybe an error. Probably should be doing at least one access control check on every transaction. And this access E has 3 different access checks. And that's possible. Maybe that's right, but it looks a little weird. So this can give you a lot of insight into you know, how you need to test this application. You'll also see that these pages have a bunch of different encryption algorithms, which is definitely weird. Some of these pages have multiple different encryption algorithms, which is probably not right. So some easy checks you can make on the application. Now let's try this with different users. I put these buttons in just to switch users easily. So I'm just going to switch to user A, hit access A and B and C. I'll switch to B, hit access A, C, access A, D, access A. And for E, I'll hit all these. And our instrumentation in the background here has gathered information on all that. And so now you can see when I look at the coverage matrix here, I can see exactly what I've hit with what roles. And because I have the access control information here, I can see very quickly that I should probably test access B with a user that has role B. And I haven't done that yet. So there's a big gap in my testing right here and other places in this model. I spent a lot of time doing access control testing. I found many very serious flaws in applications in the access control area because it's really hard to test. Nobody really does this, but it's a critical area. It's been in the OWASP Top 10 since the very first OWASP Top 10, but you know, people claim their tool analyzes the whole OWASP Top 10, but they really don't. They skip access control and authentication and other things. So this is a way of gaining insight into access control and allowing you to just see errors very quickly. So that's why I think this instrumentation-based observability is really powerful. And you can find a bunch of other things. You can find, you know, access to unauthorized files, like if we go to this XXE lesson, I think, is this, I'm not sure this is gonna work. We can detect access to, oh, maybe there's a different lesson. I can't remember which one it is. It includes path. I think if you try to access something like this file here, I think I have this set up to detect anything that's in the Etsy directory. Anyway, doesn't seem to be working right now. But again, this is all just you know, just my little experiments. So the idea here is you can create these sensors to detect really important, powerful things easily. And to me, that's the essence of turning security into code. If you look at DevSecOps a lot, you'll see people talking about turning security into code. This is really it. Okay, so let's go one step further here and talk about preventing exploits with instrumentation. So this is really going beyond testing. This is talking about using instrumentation in production. And this is to just really get you thinking about what can happen here. In this example, this sandbox agent we'll look at in a second, what this does is it has 2 sensors. One sensor to track whenever you're inside the servlet service method, that's sort of the main transaction loop in a Java EE app. And another sensor in the Java lang process builder.start, which is kind of the way of starting a native executable in Java. And we're going to instrument this with the sandbox advice. And all this says is, if you're in the scope of the service method and you try to run this process builder.start, we're going to detect that, we're going to log it, and we're going to throw an exception to prevent it from actually running. So when we take a look, let's make sure we can do this. So this is using the old agent. This is the access control agent. If we run here, there's a command injection flaw here, and we can run this and pop up a calculator, right? So let's try it now with our sandbox agent, which we just took a look at, and I'll just start that here. So we got the agent installed. Again, the performance impact from these things is negligible, by the way. I measured it just the other day, and the sandbox agent adds about 6 1/millionths of a second to a round trip request. So it's really insanely fast. So now let's try the same lesson. We've got our same lesson here. We're going to submit, and this time, I'll zoom in on this so you guys can read this. The application threw an exception. It says, hey, security exception, access to processbuilder.start from within the servlet.service scope is prevented by security sandbox. And you get the full stack on exactly who was trying to launch that. You can see it's in command.jsp on line 142. All the details. Actually, now that I think about it, we should really log the actual command that was trying to be started. Maybe not put it in the exception because you don't need to tell that to the attacker, but it's certainly worth noting here the application actually logs it. So a really powerful technique for making your applications more secure. And I just want you to think about this for a second. Imagine that we can stop people from misusing this processbuilder.start. That's incredibly powerful. That's how most exploits happen. That's how the Equifax breach happened. That's how the deserialization attacks happen. There's most of the major exploits that you read about rely on an RCE, creating a native process on the application. And we can completely control that. We can filter it out so that it can't do dangerous stuff. This is very different from trying to block attacks at the perimeter. Perimeter blocking is, it's noisy at best because all you have is the HTTP request. And it's very difficult to know if something is a real attack. Like, what are you going to do at the perimeter? Open up the serialized object and look inside it to try to figure out if there's an attack in there? You can't possibly do it. In modern web traffic, if you guys are pen testers, I'm sure you know, it's all JSON and XML these days. It's all going to APIs. It's a lot of serialized objects and web sockets, and very difficult to actually pen test in that kind of environment. So that's why I don't like WAF for this kind of thing. It's much better to build this protection into the application. Okay. So you don't have to write all this stuff yourself, although you certainly can. I meant to show this. I'm going to be releasing at some point here in the near future an instrumentation toolkit. And I'll just give you, this is a sneak early preview of kind of the configuration file, but it will allow you to create sensors like this in YAML. This one captures the current route, like what request was being accessed. This one will grab the user, parameter names, and so on. And then when we get down in the security section here, you can grab ciphers, you can grab unparameterized queries. This is the one we just looked at in our first example. Use of files, expressions. If you wanted to find expression language injection in applications, you could add this sensor. Even identifying the use of credit cards is pretty easy here. So, a lot of power here. This will make it easier to experiment with experimentation. And so, keep an eye out for this project. And if you want to help, let me know, because I could certainly use the support. All right, so back to my slides here. I just want to talk about sort of the commercial uses of this instrumentation technology. IAST, or Interactive Application Security Testing, is designed to detect vulnerabilities in both custom code and libraries during normal use. So all you do is add the agent exactly the way we did, use your application normally, and IAST will detect vulnerabilities and give you all the details about them. So this is a powerful way of leveraging IAST during development. And it has a lot of the characteristics that Keith was talking about earlier. It gives instant feedback. It's very accurate. You can use it in your IDE or in your pipeline. And so you get that kind of instant feedback loop, which is kind of the second way of DevOps. Then RASP is the use of instrumentation to detect attacks and prevent exploits in both custom code and libraries. So this is interesting. Here, you can do what we just did and identify an attack and prevent it from being exploited. It can be very accurate because you have all the details, all the context of what's going on. So this is, for me, this is holding out hope that we can actually stamp out whole classes of vulnerabilities like expression language injection and XXE and so on. So I encourage you to think about deploying RASP. It's a very effective way to make yourself invulnerable against many classes of vulnerabilities, including a lot of them in the OWASP top 10. I believe fundamentally that security just works better from the inside out. In the old days, it kind of made sense from simplicity point of view to just put a firewall around stuff and scan from the outside. But today, I don't think that makes sense anymore. If your infrastructure is spread across cloud and containers and data centers and third-party providers and so on, there is no way to create a perimeter around that. But you can add security instrumentation to each of the places where your code is running. And it's not just about the application layer. It's called IAST and RASP at the application layer, but it also makes sense that the container layer with products like Twistlock and Aqua, host layer with Carbon Black, and maybe the network at Threat Stack and things like that. But this is the modern security stack in my mind. We're moving from this model where we had one perimeter around everything to now everything has its own, think of it maybe micro perimeter, or actually beyond perimeter, it's actually infused directly into the stack itself. I think that's the more scalable, more flexible, much more DevOps-y kind of approach to security. And in fact, it gives you a lot more security in the end. Both IAST and RASP are standard. So I don't know about the UK standards actually, but if you look at the NIST FISMA 853 standard, IAST and RASP are there. Same thing with the PCI software security standard. Both IAST and RASP are in there. So this is ready for you today. I want you to think about turning security into code. Somebody's scribbling on my slide. I love it. Here you can see adding this instrumentation inside your applications in development to get instant feedback to developers, in your CI/CD pipeline to get that final assurance, and then in production to get visibility into who's attacking and what kind of attacks they're doing. This stuff works in all these different environments, has integrations in all these different tools. So it's really a nice way of getting that full cycle. And when I think about it, you think about the vulnerabilities being in the code that comes through this pipeline, and there's vulnerabilities in there. But to me, if you take it one step farther, every vulnerability that ends up in your code is there because you missed something in the pipeline. So really, isn't the vulnerability in the pipeline? Like if you have a really good pipeline, any code that goes through it should come out with the security built in and should produce the assurance that you need to generate it. So I think it's useful to think about enhancing your software factory. That's where the vulnerabilities are. And over time, what I want to see happen is I want to see you move from a place where, say, maybe you've got automation around some kinds of security, like maybe you're testing for certain things today. What I want you to do is turn all the manual stuff that you're doing today, like hopefully you're testing for access control and authentication and all the other best practices and security controls that you have. Hopefully you're testing them. You're probably doing a lot of them manually. I want you to turn them into code and raise the bar over time. So pick the next most important thing. I don't know, it might be SQL injection. It might be, SSRF is like a big thing today. Maybe it's expression language injection. I don't know. But write something as part of your pipeline that will raise the bar here and get you to a stronger state afterwards. Okay, so let me try to sum up in one slide. So the old way of doing things, traditional security, you take your code and your libraries and you feed them into some set of tools that you're going to try to run, SaaS tools or SCA tools. You're going to end up with a lot of false positives, and security team's going to get this giant backlog, which slows them down. And you can see it's going to create a big delay in the pipeline. And then you probably have to repeat that at multiple stages through the process. So, later on, you're going to have a CI/CD run that's going to generate more findings, more experts. Later on, you're going to run DAS probably, maybe do a pen test or try to set up a WAF. You're going to get more feedback. All these experts are going to have to deal with all that. Eventually, a lot of it ends up getting pushed onto the developers who get irritated, and this flow doesn't work, and you end up killing the value that you were trying to produce in the first place. So the modern approach works differently. Here, we're going to package the whole application together, and we're going to inject instrumentation into that whole stack so that it can be self-testing and self-protecting. This gives us very fast feedback directly to developers. We're not going through this whole loop with experts. We're going right back to the developers with accurate vulnerabilities. And when we look at the rest of the process, we're going to repeat that testing in the CI/CD stage and staging, even in production where we start finding attacks and blocking attacks and giving that telemetry back to development teams so they can prioritize. This works continuously and it works at scale because it's distributed. Every application is doing its own testing as opposed to having to go to a siloed security team to get tested. That kind of knocks out the bottlenecks, and you can really accelerate the production of business value, which was the whole point. So let me sum up with this. I don't think application security is hopeless. I'm still optimistic. I'm not saying that technology alone can solve our security issues by any means. Good security requires the right mix of culture and people and processes and technology. But instrumentation can create a platform where security and development can finally work together because they're talking all the same language. It's really, the key is getting security code into production. And so, both IAST and RASP and this custom instrumentation will allow you to do that and innovate faster. If you're interested in trying out IAST and RASP, Contrast offers a totally free and full strength application security platform called Contrast Community Edition. It's available now for both Java and .NET. And we're going to release our Node, Ruby, and Python support in CE as well. It's for one application, so you can get a sense of how it really works, but it's free and full strength forever. So I think it's a really great deal for lots of small companies. If you're doing a pen test and you can talk your customer into adding an agent to their application that you're testing, it'll give you a ton of great data really fast without any extra work. So might be useful. And really that's it. So I'll try to start looking through the questions, but please feel free to ask an audio question too. I'd love to take those.
Hey Jeff, thanks for that. It's Nathan here.
Yeah.
As one of the leaders, I'm actually going to jump in first, actually. That's my prerogative. Just to say, I did like your analogy about the pipeline, about the issues in the pipeline. You compare that to, say, a car manufacturing pipeline where cars are, they're just in time, they're taken off the conveyor belt and out, there's your new brand new Ford or whatever car of choice. If we had to then go and retrofit a widget at the end of that pipeline as it spits out to make something work, whether that's a brake light or let's take a brake light as the thing we desperately need. That car manufacturer, if they continue to do that, that car manufacturer is probably going to lose money, probably won't exist. It's just a terrible methodology. So if we can translate that into software, as you describe in the pipeline, well, that's, for me, that's the ideal scenario.
That's exactly right. And car manufacturers are a great example. Like, look at the Tesla factory. It's insanely automated. I guarantee they have sensors that, at some point during the process, someone, 10 taps the brakes and makes sure that the brake lights come on before that thing rolls off the assembly line. That's exactly what we're talking about doing here.
Yeah, no, absolutely. I've got a question about IAST actually, Jeff.
Yep, shoot.
In your experience of IAST, have you ever come across a situation where how often do you find developers or organizations that use IAST, their test coverage just being not up to scratch? Because I imagine that IAST, the success of IAST, now you can correct me because I've not used IAST much. I imagine the success of IAST is directly associated with a level of test coverage.
Yeah.
Poor coverage, poor results of IAST, and that's not a IAST issue, that's test coverage. Do you find that's an issue in the, when you speak to customers and anecdotally?
Yeah, so that's a great question. And what we've found is that even the kind of the mediocre software projects using IAST get about 60 to 70% route coverage. What Contrast does, how we deal with this problem, is we measure route coverage, which means we use instrumentation to detect the exposed attack surface, and then we keep track of how much of that attack surface has been exercised. So we have a really good measure. We have a really good measure of the denominator. And then we just measure how much of it have you actually covered when you're doing your normal development and testing. Whether it's automated or manual, doesn't matter. And so even a crummy project gets about 60 to 70% coverage. The higher functioning DevOps projects tend to get much higher because they have more automated testing. But what's interesting is if you actually measure what you're getting out of your SAST or DAST tools, I think you'll find that the coverage is considerably less than 60 or 70%. Now, DAST tools are easy to understand because DAST, you have to crawl the application and it's going to make mistakes and miss a lot of the code. I think if you hook up a code coverage monitor to a DAST scan, you'll see it's not covering much of the code at all. But SAST tools miss tons of code because they don't understand all the entry points to the application. They may not understand the framework or the annotations or how you've built your application. So they don't really understand, the attack surface. And then they make mistakes while they're crawling too, because of things like dependency injection and inversion of control and other control flow structures that make it difficult, like reflection, for static tools to actually effectively crawl the code. So I think you'll find that static tools only cover, a small percentage of the application. Anyway, that's why they make a lot of mistakes. So what we've done is we've said, here's what coverage you're actually getting. You get it for free because it's based on the testing that you're already doing. And we think the best way to get coverage is to leverage the things that projects are already doing. Rather than trying to reinvent it in a security tool, let's use the folks that are experts at this, the Parasofts and all those software testing companies. They're really good at generating test coverage. So let's turn all of that into security coverage. I mean, why would you want to do it twice? And then we try to give you a path to 100% by showing you, here's the routes that nobody's ever tested. And I'll give you an example. I was at a major mutual fund company a few weeks ago, and they've been using Contrast, and we discovered some routes that they didn't know about. They were actually woven in by the framework. Spring, and you pen testers should know this, Spring Boot weaves in extra parameters, extra functionality into applications, extra endpoints. And you can do crazy stuff. You can get all the environment variables. You can even do a heap dump right through these added functions. And it's amazingly powerful. And these were exposed vulnerabilities at this mutual fund company that we found and told them about, and they were greatly appreciative. But static would never have seen that because it's not in the source code. Dynamic tools would never have found it because it's never linked anywhere. But it was really a, blazingly obvious vulnerability if you knew where to look. So great question. Sorry for the long-winded answer, but I'm really passionate about getting companies to 100% coverage of security. Because if you're not doing that, if you don't have a path to that, what are you going to do? How are you going to improve coverage with a static tool? You can't.
Yeah, I love that idea, Jeff, of using the existing test coverage of the functional scope to kind of drive through the code paths and actually, you know, discover vulnerabilities. But I've got a question, just I guess a little bit from the left field. I loved your introduction, actually. I thought it was great, where you talked about, you know, the long history of, you know, different attempts to fix AppSec that had kind of not worked out. And I bet, you know, I bet there's somebody even older than anyone on this call who could tell the same stories, you know, going back into the 70s of that same
Absolutely.
Same failure to crack that nut. But so here's my question, right? So one thing I loved about the OWASP top 10 was how accessible it was, right? I mean, it's so accessible that, you know, people can grasp hold of it, even if they don't understand the deep tech, and it can inspire them to learn about the technology and what is cross-site scripting and what's the difference between authentication and authorization and all the rest of it.
Yeah.
So really deep, like amazing, really deeply technical talk, but and I think you've inspired me to be interested in instrumentation. But what's the on-ramp? I mean, so one thing we have is you know, we really like the fact that, you know, we have folks come from the universities or folks from, you know, who are doing college, who want to get into cybersecurity. But how can instrumentation be an on-ramp into security rather than, you know, a kind of something that's super technical and kind of a bit inaccessible?
That's a really good question. I mean, I think actually the upshot of instrumentation for non-experts is that they should really just be the consumer of the output of instrumentation, which is like very detailed findings, really explaining the problem, and not, you know, some static analysis finding that says something that's incomprehensible and doesn't map to the code very well. So, you know, I think of instrumentation as a way for experts to have a force multiplier where they can take this knowledge that's like, you know, it's stuck in a training course or in some requirements document or on some OWASP wiki somewhere. Let's take that and turn it into code that people can, you know, everyone can use on their desktop so that they can get the value out of that knowledge. You know, my goal in creating OWASP was to get the knowledge out of the consultants' heads and into a public forum where everyone could benefit. And we did that, but we didn't take it far enough, because we actually have to go further. We have to take that knowledge from, you know, being industry accepted, like you should use parameterized queries, and turn that into code that can push out in a distributed way to everyone in parallel. That's really the only way we're going to solve this problem. I think if it doesn't scale, it just doesn't matter. Oh, I think OWASP's goal last year was to train 500 or I don't know, 2,000 developers or something like that. I was like, come on, OWASP, that's not going to change anything. There's 30 million developers in the world. Who cares if you train 2,000? Sorry, OWASP.
No, I agree. I mean, scale is the problem. There's a couple of things I wrote down when you were talking, you know, but how do we fix the economics of security?
Yeah.
John Ayre has got a question. How do you make sure injected sensors in production don't introduce errors or interfere with normal functionality?
Yeah.
And there was a related question that's a bit different from above. How do you make sure that, how do you know that instrumentation isn't going to introduce vulnerabilities of its own? I suppose two questions.
Yeah, great. Okay, let me answer the second one first, because I do hear that quite a bit. So the idea that the instrumentation is going to introduce a vulnerability is pretty unlikely to me. The instrumentation adds code in just the way that you would have done if you were manually adding instrumentation to your application. Like if you went crazy with logging or something and put logging everywhere in your libraries and frameworks and everywhere, that's kind of what it ends up doing. Some people think the instrumentation itself could be abused, and I just don't think so. It's like, in order to abuse it, you'd have to already have owned the application, it doesn't count, right? The second question is really interesting. about, how do you make sure you don't break the application in some way? And aspect-oriented programming, came out, I don't know, 15 years ago or something, and people tried to use it, but it did introduce errors. I think you really need to be careful with instrumentation. I'm showing this example up here, which gives you some examples. Like, if you can see, this framework allows us to suppress exceptions that happen during the instrumentation here. So, this is one way of safeguarding this from, so anything that happens inside this instrumentation, any exceptions that happen will get caught and discarded. They won't affect the operation of this, the class that we're instrumenting these SQL queries. So that's just one thing. There's a number of different protections that we put in place to make sure that anything that goes wrong in the instrumentation won't break the application. But even so, I think the best thing, just think about this. The best thing is that you can test the application with the instrumentation in it. Like, it's all part of your pipeline. So write the app, use the instrumentation, test it, make sure everything works, and then push that into production. That's the way to make sure everything is safe. So that's how I think you ought to do it. Any other questions before we wrap up?
There's got to be. I mean, so yeah, I really enjoyed the section about DevSecOps, actually. And when you said it's about changing security and not DevOps, how did you come to that conclusion?
I'm sorry, which conclusion?
The DevSecOps is about changing security, not about changing development or how systems are operated in the cloud.
Well, a little bit is just history, right? Like, I think if you look at the history that I showed at the beginning of the presentation, all of those efforts, all of them, were an effort by security to force development to change. And we do it with all these, some are, soft techniques, other of them are very guerrilla tactics. We put blocks in deployment pipeline. We set up gates and guards and reviews and penalties and all sorts of risk, ratings and shaming and all that. And development, for the most part, that stuff just bounces off. Like, they don't care. They're not motivated by that. They're not incentivized by that. So it doesn't really matter. And I believe the only way for security to be relevant is for us to figure out a path into production. What I mean by that is, every application should have some security code in it, defenses and tests as part of the pipeline. That's all code that has to run. And security has to figure out a way to get code into production. Instrumentation is a really interesting way of getting code into production without having to go through the whole development pipeline on every project in your company. You can build these things and get this code into production in a very effective way without, having to put champions on every development team and so, which is a great idea, but it's not going to scale. So I encourage you to really think about, what effect are you actually having on production, and focus on that. It's the only thing that's going to work.
Jeff,
Cool.
It's Nathan again. I've got a question from Dave, it might be rather tongue-in-cheek. He said, if developers fully understand how to prevent problems and implement it to fix this, we wouldn't need any security testing tools. What do you think about that?
Well, I think that's a little naive. I think you kind of get what you test for. So, yeah, I mean, in theory, sure. But if nobody's watching, people are going to start making more and more mistakes. It's like saying, like, well, we didn't find any problems in the financial audit, so I guess we don't need auditing anymore. I don't think that's really likely to encourage a culture of security in your organization. I thought the question was going to be about, like, if we do all the right testing in development, why do we need protection in production? And I think that's a fair point. because actually they do kind of the same thing. But the fact is, I've done this long enough to know that we're never going to get development perfect. And there will be new vulnerabilities and things that come out that we need protection in production. And even if we were perfect in development, we would still want to have protection in production just for the visibility of it, just to know who's attacking us and where they're targeting and what kind of attacks they're sending our way, so we could know how to prioritize. So I think you really have to do both, you know, shift left or extend left, if you will, and extend right. Don't forget about the extending right. It's probably just as important as the shifting left piece.
Yeah, no, absolutely. Jim, any others?
So there's a there's a question about the OWASP top 10, and I'm you know, I'm going to try and ask it. So yeah, I mean, so Roger's asked, what is the future of, what is your future of the OWASP top 10 if it's a failure now? Maybe that can be rephrased, says Roger.
Yeah.
Is there a better alternative? So, and you know, I would say that the OWASP top 10 has proved its worth, and a rolling stone gathers no moss. Yeah.
Well, that's a great question. I mean, it's very, I can't imagine like it going away because a lot of people rely on it, and it is a good place for a lot of companies to start it. I think it raises the visibility up to higher levels in an organization because they can ask a simple question like, are we doing the OWASP top 10? And so it sets a kind of standard, but I don't think it's been effective at changing the game. And you know, so I don't see it changing the game in the future. I think it'll continue to be a nice lighthouse for different classes of vulnerabilities and kind of good marketing for OWASP, but you know, I don't think that it's really gonna, you know, if we stay on the course we're on, then I think in 20 years we'll be having this same conversation. I know we are, because I've been having this conversation for 20 years.
Well,
It's
Jeff,
the
that leads on to, so Jeff, that actually leads me on to my comment about the OWASP top 10 was going to be, what are you going to do the day that injection is no longer on the OWASP top 10?
Yeah, I mean, so the only thing that's ever worked in AppSec, in my opinion, is when we added ASLR and DEP to the kernel so that we could make exploiting buffer overflows much, much harder. It used to be that it was very easy. You could find a kernel exploit easily. And then we added ASLR and DEP, and those vulnerabilities all of a sudden became super hard to exploit. And so the cost curve for the attackers went way up. And it didn't totally eliminate it, but it made it way, way harder. And notice that wasn't about finding the vulnerabilities, it was making them unexploitable. And so what we're on about with RASP is about making application security vulnerabilities very difficult to exploit. And so we've now done that for, you know, SQL injection and XXC and SSRF and unsafety serialization and command injection and file path traversal and a bunch of others that have plagued our industry for a long time. And simply by adding RASP to your application, you can raise the bar for the attacker dramatically. And so I think there's some potential there to finally start to stamp out a lot of classes of injection. You know, I don't know, tomorrow some idiot's going to make a new parser and we're going to have a new class of injection. I don't know what it's going to be. It'll probably be a Lambda injection or something, but you know, it's, I think this approach of using runtime instrumentation to get right into the vulnerability and make it unexploitable is the key.
Awesome. Well, thanks, Jeff, so much. Really awesome and deeply technical, but also very general and, you know, reflecting on your history in AppSec, and I really enjoyed it. And there's a couple of things I've written down that I'm gonna kind of think about coming out of this. Equally, Keith, thanks so much for your talk, which was around DevSecOps, and thanks to everyone for joining. As always, it's it's the community that makes OWASP. And I think, you know, I just heard in the background the NHS clapping going, and I'd forgotten that was going to happen. So that's a bit of an awkward thing. But you know, perhaps you know, the fact that the community can still come together and have an awesome session like tonight, I think is awesome. So obviously we can't hear a round of applause, but round of applause for everyone, really. Jeff, Keith, and everyone.
Thanks, really appreciate it.
Yeah.
Well,
And
if I didn't get to your question, please reach out to me on LinkedIn or Twitter or something.
Yeah, great stuff. Thanks, Jim. Thanks, Jeff. Thanks, Keith, from me as well. What a great first virtual event we've put on. Yeah, I'm stoked that we've had such a great a number of people join. We've had two great speakers. We've had great engagement as well. So it really bodes well in these difficult times that we can still do great events virtually. So once again, thank you everyone for attending. Thanks, Jeff, for stepping up. Thanks to Dave, Lindsay, and the other guys and folks at Contrast. Thanks for Keith for coming on. And hopefully we'll all see you out there in the community spreading great stuff about AppSec soon. So I think that's it. I think that's a wrap. Thanks, everyone.
Thanks, Nathan. Thanks, Jim.
Thank you.
Cheers, Dave.
Thank
Thank you.
Bye.
Bye-bye.
Thanks, guys.